Question number 31. A coil of wire rotates with a constant angular speed omega in a uniform magnetic field. The variation with time of the EMF is shown over here. Okay. The angular speed is changed to 3 omega by 4. 3 omega by 4. Means initially it was omega. Now it became 3 omega by 4. Which means what? The rotational speed is now reducing. When the rotational speed is reducing, what will happen? The EMF will also reduce. Let us see. What is the amplitude of the EMF and the time period of the variation of the EMF in the coil after the change? What is the new EMF and what is the time period? Second part is quite easy to answer. Why is it quite easy to answer? Because you know omega is equal to 2 pi divided by t. Omega is inversely proportional to the time period. So if omega becomes a 3 omega by 4, then time period becomes a 4t by 3. Okay, so only the coefficients get reversed. 4t by 3. So thus you can see this t dash becomes 4t by 3. Okay, now what we need to do is, what is the earlier t? Okay, earlier t here, from this expression you can find. So from here to here, okay, from here to here it is 1. So I do not know what is this. What I will do is I will take from one full circle is here, and from here to here one more cycle over here, and half cycle. So if you consider this distance over here until this point, this is your 2.5 time period, right? See, one time period here, your second wave here, your half wave over here. Because intermediate values are not given, right? So I cannot just assume anything. So I will take this 2.5 time period is equal to 2 milliseconds. 2 milliseconds. So one time period is equal to 2 divided by 2.5 milliseconds, which should now be equal to. So calculate the difference. Let's take up this value. 2 divided by 0.5 will be equal to 0.8. So the time period is 0.8 milliseconds. So what is this? This is the capital T of the initial wave before you increasing or decreasing the value of omega. Now with the change in the value of omega, your T dash will now become what? It will be 4 by 3 times 0.8. It will now be equal to how much? 4 into 0.8 divided by 3. That is once again on our front. Multiplied by 4 divided by 3 will be 1.06. So nearly 1.1 millisecond. 1.1 millisecond. So who is right here? So these two are incorrect, eliminated. So these two can be right. Now similarly we need to get the value of EMF also. You know, in a coil and a magnet experiment, when you take the magnet and bring it faster to it, okay, then what will happen? So the magnetic EMF, the EMF due to the speed will increase, right? When the velocity is larger, EMF will increase. In a similar way, in an armature coil, if you put two magnets, okay, and you start rotating, when the rotation is slower, EMF generator is also slower. When the rotation is faster, EMF generator is also faster. So which means somewhere your EMF is directly proportional to the angular speed, right? There it was linear speed. When you drop a magnet to a coil, it was linear speed. Here it is angular speed. So thus I can now write E proportional to omega or E dash proportional to omega dash. So E dash by E is equal to omega dash by omega. Okay, now what is omega dash? Omega dash is 3 omega by 4. So I have slowed down, so it will be 3 by 4, because omega and omega will cancel it, right? And thus your E dash would be equal to 3 by 4 times E. 3 by 4 times E. What's the value of E? Let us look at that E also here. This initial EMF here was seen to be 10 volts over here. So I can now write this as 3 by 4 multiplied by 10, which will now be equal to 3 2.5, which is equal to 7.5, right? So answer should be 7.5 and 1.1. So the answer or the options D.